Let's take a look at number 6, which is by way of some examples. To have a good generalization of what we need to know ahead of us. And what about project examples? Let's look at a Wanda project first. What about this Wanda project? How many rounds of programs have you done? The first round of the program is a double take program. The second round is the flatbed program. The third round is the flat and skinned program. And in the end? Still doing the double take program. Then we need to understand the concept of a single and a double. It's straight board. The price of cardboard is about $250. And the price of the single? It's probably just an extra $30 or so. 250 plus 30, $32, $10 or so. You'll find that the price difference between the tablet and the single isn't really that great. But the hyperbolic price is different. What about the price of hyperbolic? It could be multiplied by 2 or by 3. Because it depends on how hyperbolic, and the difficulty of machining. Hyperbolic shipping costs more. Because the car can't hold much cargo. And then when we know about these problems? Of course, here is what you need to know to take this course. I'll flatten it here, too. Leveling is one of the most important. It's all about how to spread it out. Then let's look at this scenario first. Firstly, just getting started. It's designed to be a 2-lift program. Hiccup. It's a program like this. But look, it's a double orange. But the rest of the world is double lifting. It doesn't have the same degree of double orange. But the price is still that everyone must have been quoted by the price of the window. So what about the epidermis? Maybe if I make an offer. The skin will probably cost about $40 million. The cost will be very high. And then Party A thought this looked very ordinary. It's not really that far off from the monolith. But it's expensive. It doesn't feel like a landmark. And then? The model probably looks like this. Let me show you. It's probably one of these. After that, take a look at the model. Check out the look. Just about every piece is hyperbolic. It's all curved. It's these two looks that stand out a little bit. And then? Let's look at the second scenario. I think it's more expensive. And then the styling isn't really that eye-catching. And then? Just design a straight program. Just optimize it all too. It's about optimizing the hyperbolic full team into a straight board. Hiccup. I've talked about 4 things to optimize this into a straight board. The common surface straight board is the cheapest, right? What about this price? Maybe it was originally reduced from 30 million to 10, from 40 million to 15 million. And with this look you'll realize that this look is actually probably even better than the hyperbolic look. Well, that's the power of optimized design, then. Maybe all of a sudden this program drops the quoted cost by $20 or $30 million. But Party A still thinks that, not very on point. And then? We made him some more. This is a rendering. Some renderings of the straight board scheme. Then we'll make him some more. And then? You've done both programs. The original program was a double body, wasn't it? Because it also adjusts this corner plate. So the area will be reduced. And then what is the adjusted program? And then what about the adjustments? If you're going to be involved in production construction, you're not all cardboard with this number. You're gonna braid it, aren't you? You'll need the number of each board. You'll need the number of each board. And then? Putting the total of all the boards. And then how many rectangular panels? One of the triangle panels you can list this all with a logo. There are 44 triangular plates. And then? What about the rectangular plate? It's over $3,000. That's all there is to it. The total area is so much more. And then? That is, take all the side lengths and side numbers. There are 3 more coordinates that can be derived. Then give it a comparison. That way you can estimate the price. The corresponding number of the dimensions will give a report to the A party. And then we thought it was cheaper. But party A is not short of money. Right, but I just need good programs. Then we designed some more epidermal programs for him. Let's take a look. And the third? I didn't do the rendering. It's still the cardboard program. What about this cardboard? Made a standout. And a gradient. It's got to be a lot more material, doesn't it? But then? This look is going to be even more different. Just one parameter of a tubular consequence. Let me show you a picture. Here's the rendering. This rendering doesn't actually render. This picture looks like the grain looks a little clearer. It's probably a scenario like this. This cost is definitely more expensive than the straight program. Show you a model picture. After that, here's the split chart for the double inning. How does this divide and conquer? This may be a concern for everyone as well. It's in the classroom. It'll be covered in the course. And then show you this cardboard scheme again. Where's the cardboard solution? Besides this cardboard program? We also designed some hollow shapes for him. So these open windows you see. Let's see. It's just that every board has some openings in it. And then the size of this opening. Size of holes to be cut in each board. It's a gradual process. This is a step closer than the just a little bit prettier. Then look at that cardboard protrusion scheme. This is the model. You can see it clearly with this model. It's just that the height of its protrusion is high in the center. And then gradually it's coming up to the edge. Fade away. Such a good looking. It's fading to the edge. Here's the protruding program. But of course the A side of this bulging program, there's also the straight plate option. There's also the straight casement option. Actually, they're all way cheaper than that double lift. But it should still look better than this double lift. A little bit more different. But party A thinks it's not in place. And then we're out again. Next program. What about the next program? That's the final proposal. In the end, he was more than happy with the look. This one's under construction, too. It could all be built by October of this year. And then this just started out as some fire windows. But the ladder problem removes these window sections in a different way. It's been changed back here. What about this program? It looks very hyperbolic, doesn't it? Sympathetic. In fact, he's been pursuing this. Very sexy. Very streamlined. Finally decided on this one board model. Also give you a look. What about this model? It's the model I modeled the most recent split. So this fire window ended up being removed. Some of it is because it's just not a good look to have these windows So that kind of goes out the window. And then this one opens the window. Party A likes this. This one gradient. I've made a window in the back. A look like this. It's relatively sexy. And then this is some light trough because you also have to take into account the effect of a very night scene. Gotta make some light troughs. And then here's a layout. Most of them are split. It's split. And what about this split? You need to follow the division principle. You'll have to. How it's split. People are probably more concerned. And then it's divided according to a form. I'll show you. I'll hide some lines first, haha. It's based on these Kia lines. These carry A. We need to light the logo. Let's get this line done first. Then use these lines to split the exterior. And in the end? That's the program. And then what about doing this program? You'd know. You'll learn. It's all about how to do full styling. How to make a split based on the structure including some designs for some light troughs, and some plate numbers. Some enhancements to some of the new productions. Then you can solve a lot of problems. What can you learn? Extracted from the new model. Inside the CAD plane These are some of the questions you may be concerned about, including some extractions at the beginning of the inverse. Then flatten the missing side. Then you need the main frame line on the face. How to get to the main frame line, and then its some point number. Then measure the SYD coordinates of the point. How to generate square tubes, and then give it a number. Then the analysis of the board. You guys need to get a handle on it, too. Which are flat? What are the double go boards? Then go up to the number of warps on the board. And then limit the scale of the warp to what? These may all need to be learned. And then layers, how to layer There are ways to equalize. There are ways to equalize. How to do it just isn't the size of the head. It's just a more balanced approach. It wouldn't have been the size of the head. Right, if you do a 4-point hook face, this top turns over to control the curvature. Optimization board. Optimize the cost and so on of these. Of course this case follows the buildings. It's split according to some lines of structural calculations. There is no other way to do a split. Here are some of the lessons we can learn from this case study. And then what? Well, what about the next case? What kind of points will you learn?